All right, welcome to the deep dive. We are ripping into a stack of sources today that point to something genuinely exciting happening. We're talking large language models.
Yeah, specifically about a company called DeepSeek. They're really shaking things up.
Exactly. We've got a couple of recent pieces on their latest model updates, sure, but I think the really fascinating part is how they might be building these things. It seems
Well,
different, maybe cheaper.
well, that's the core of it, isn't it? Challenging that status quo. I mean, for years, building top-tier LLMs, that's been a game for giants. Massive budgets, huge compute clusters.
Right, the kind of resources only a few big tech players have.
Exactly. And DeepSeek seems to be showing, hey, maybe there's another path.
And that's really our mission for this deep dive. We want to unpack what's new with their updated model, sure, but really dig into these innovative techniques they're using, techniques that might dramatically lower the cost.
And then look at the bigger picture. Why does this matter? Who benefits?
Yeah, why does it matter to you listening right now? We think it could be about making this cutting-edge AI way more accessible than ever before. So imagine getting a handle on how that could happen. That's what we're diving into. Okay, so let's jump right in. The headline news from one source. DeepSeek updated their R1 model. The new version is called R10528.
And this is getting attention, especially in the open weights community.
Right, open weights. Maybe quickly explain what that means.
Sure. So you know how models like, say, GPT-4 are closed? The company keeps the model's internal workings, the parameters, the architecture details secret. It's their proprietary tech.
Okay,
Open weights models are the opposite. The creators release those weights, the model's brain, essentially. Anyone can download them, run them, study them.
gotcha. So when an open model starts performing near the level of the big closed ones from OpenAI or Google.
That's a very big deal,
Yeah.
yeah. It means that kind of power isn't locked up in just a few places anymore. It spreads the potential around.
And this R10528, looking at the specs here, it's quite a beast. It's using a mixture of experts architecture, MOE.
Which means it has a huge number of total parameters, 685 billion in this case.
Really?
But the key is only a fraction are active at any one time, about 37 billion, depending on what you ask it to do. That's up slightly from their previous version, by the way.
Okay, so it's big, but efficient in how it uses itself. It can handle pretty large inputs and outputs, like long conversations.
Yep, the source mentions up to 64,000 tokens context window, both in and out, plus useful features like JSON output support and tool use capabilities.
And there's a smaller version too, right? The R10528 Qwen 38B.
Yes. And this one's really interesting because of accessibility. It's smaller, obviously, 8 billion parameters, but the source highlights it can run on a single GPU
Just one GPU.
with as little as 40 gigabyte of VRAM needed. That's pretty remarkable.
Yeah, that suddenly puts it within reach for a lot more people, developers, researchers, maybe even hobbyists without,
Yeah.
supercomputer access.
Absolutely. It lowers that hardware barrier significantly. And while it's based on an existing model, Qwen 38B, the important part is they've distilled knowledge into it.
Distilled, like transferred smarts from the big R1 model.
Kind of, yeah. They tried to capture some of the reasoning capabilities of the big R10528 and pack it into this smaller, more efficient form factor.
Okay, so a powerful big model and a surprisingly capable small one. How do people actually, get their hands on these?
Well, they're up on Hugging Face, which is like the main place for open source AI models.
Standard practice set.
Yeah, but here's the kicker. The license. It's the MIT license, which means they're free to use, not just for research or playing around,
But commercially too.
but for commercial applications as well. That's a huge deal for businesses wanting to leverage this tech without hefty license fees. The big R1 is also on DeepSeek's own API and in their app.
Okay, and let's talk API pricing, because if they're claiming efficiency, the price should reflect that, right?
And it seems to. The rates mentioned are quite low compared to other top models. Something like 0.13 cents per million input tokens, $2.19 for output.
Which is already pretty competitive.
Right, but then they have these off-peak rates too, dropping down to like 3.5 cents for input and 55 cents for output per million tokens.
Wow, okay, that's really cheap.
It strongly suggests they are achieving significant cost savings in training and running these models and, passing some of that benefit on. It backs up the efficiency claims.
Which brings us nicely to performance. How well do they actually work? DeepSeek claims general improvements, reasoning, complex stuff, writing, editing.
And they made a pretty specific claim about hallucinations, didn't they?
Yeah, a 50% reduction.
Yeah.
Specifically when it's rewriting or summarizing things. That sounds impressive, if true.
It does. Now, the sources dive into benchmarks, which, always take with a grain of salt, but they give us some comparison points. Comparing this new R1 to the old R1, the improvement looks pretty clear in DeepSeek's own tests. Like HLE reasoning score jumped from about 8.5% to over 17%. Aider coding tests went from 53% to nearly 72%. Big gains.
Okay, so definitely better than their previous effort.
Right.
But the big question, how does it stack up against the closed giants, like OpenAI's O3 or Google's latest Gemini?
Right. The source suggests it's definitely playing in the big leagues now for open models. It nips at the heels of the top closed one.
Nips at the heels. So competitive, but maybe not outright beating them across the board.
Seems like it. On some tests, like math problems on AIM or coding on LiveCodeBench, it apparently beat Gemini 2.5 Pro but was still behind O3.
Okay.
But on others, graduate-level questions on GPQA Diamond, those Aider coding tasks again, HLE reasoning it fell behind both O3 and Gemini Pro.
So a mixed bag, but definitely in the conversation. It's not lagging way behind anymore.
Exactly. It's highly competitive, making the gap between top open and top closed models much smaller.
And what about that little 8B model, the one that runs on a single GPU? How'd it do?
Yeah, that one's performance is fascinating for its size. On that AME math benchmark, it scored a really impressive 76.3%.
76% for an 8B model.
Yeah, get this. That's actually better than the much larger Qwen 332B model, and basically neck and neck with O3 Mini, OpenAI's smaller model, at medium effort.
Wow. So that knowledge distillation really worked, at least for math.
It certainly seems like it for that specific task. It shows you can get surprisingly strong reasoning in a small package, but again, not universally dominant. The source notes it didn't perform as well on GPQA or LiveCodeBench compared to some other models in its size class.
Okay, so it excels in some areas, maybe not others. Still, punching above its weight.
Definitely. Especially for specific applications where that math or reasoning capability is key.
Right. This is all leading up to the really juicy part from our second source. The how. How did they build these? How did they get this performance, apparently, without breaking the bank? Let's get into the technical weeds a bit.
Yeah, this is where the clever engineering comes in. The researchers really focused on efficiency, like squeezing every drop of performance out of the hardware while using less memory and processing power.
We mentioned the MOE architecture helps during inference, right? Because only parts of the model are active.
Exactly. That saves compute compared to dense models where everything is always on. And they trained these models, V3 and R1, on a pretty hefty cluster, 2048 NVIDIA H800 GPUs.
Okay, so still serious hardware, not exactly training on a laptop.
Oh, definitely not. But the key is how they use that hardware more efficiently than maybe others do.
So what were the tricks?
Well, the sources list a few key techniques. One big one was using a mixed precision training algorithm.
Mixed precision, meaning?
Using different levels of numerical precision for different calculations. Think of it like using fewer decimal places sometimes. They used 8-bit floating point, FP8, for some of the really heavy math, like matrix multiplications.
Okay, which is faster and uses less memory than, say, 16-bit or 32-bit.
Precisely. But they kept higher precision for other parts where it was more critical. And DeepSeek v3 was apparently the first open LLM trained using this FP8 approach.
Interesting. So using lower res numbers where possible. What else?
They really optimized how the GPUs communicate.
Yeah.
In these big clusters, GPUs are grouped in nodes, and talking within a node is way faster than talking between nodes.
Right, like shouting across the room versus talking to the person next to you.
Good analogy. And for MOE, where different experts might be on different GPUs, they designed the routing so tokens wouldn't have to travel too far, limiting communication to within a group of like 4 nodes maximum, faster local chats.
Clever. Keeping the data flow tight.
Yep. And another thing, maximizing GPU utilization. They figured out how to overlap the number crunching, the computation with the communication, the data shuffling between GPUs.
So the GPU isn't just sitting idle waiting for data. It's calculating while it's also sending or receiving.
Exactly. Dividing up the input data smartly so different parts of the chip are busy doing useful work simultaneously, less wasted time.
Feels like a really fundamental efficiency gain there. Anything specific about memory saving during inference when the model is actually running and generating text?
Yes. Another key piece, they use a technique called multi-head latent attention. The details are technical, but the result, according to the source, is dramatic memory savings per token processed.
How dramatic.
They claim their method uses only about 70 KOD per token. Compare that to, say, grouped query attention in Qwen 2.5 at 328 KB, or standard attention in Llama 3.1 at over 500 KB per token.
Whoa, okay. That's a massive difference. Less memory per token means.
Means you can handle longer sequences or potentially run these powerful models on hardware with less VRAM. It all ties back to accessibility and cost.
So you put all these pieces together. The inherent efficiency of MoE, the FP8 mixed precision training, optimizing the GPU communication, overlapping computation and communication, plus this super memory efficient attention mechanism.
You get a system that seems designed from the ground up for efficiency. It's not just one silver bullet. It's a whole suite of optimizations working together.
Which brings us circling back to that cost figure, that headline number from the source about DeepSeek V3's training cost. An astonishing $5.6 million.
Yeah, astonishing relative to the tens or even hundreds of millions often estimated for training comparable top-tier models from the big labs.
If that number holds up, it's
Yeah,
game-changing for who can build these things.
absolutely. If it holds up and is the full picture, the source itself points out the skepticism. Does $5.6 million really cover everything?
Like researcher salaries, the massive cost of gathering and cleaning training data, failed experiments, general R&D overhead.
Exactly. Those things add up fast. And we don't actually know the reported cost for the newer R1 model, just the V3. So caution is warranted on that specific number.
Fair enough. But even if the real all-in cost was, say, double or triple that, $10, $15, $20 million, that still feels like a massive step down from the $100 million plus figures sometimes thrown around.
Agreed. And this isn't DeepSeek's first time releasing a competitive model seemingly on a tighter budget. They're consistently showing it can be done more affordably.
And that feels like the really significant point here, the behind-the-news angle. Forget the exact dollar amount for a second. They are proving you don't necessarily need Google or OpenAI level resources to build something that competes at the cutting edge.
Precisely. They and others in the open weight space, like the teams behind Alibaba's Qwen models, are actively closing that gap between the open and closed ecosystems. Performance is getting closer.
And by developing these efficient techniques, the FP8, the communication tricks, the memory-saving attention, and then talking about them.
Yeah, sharing the methods used for V3 and R1.
They're not just helping themselves. They're potentially giving a playbook, or at least strong inspiration, to other teams, academia, smaller companies, showing them ways to build powerful AI more efficiently too.
It empowers a much wider range of people and organizations to contribute. Plus, being transparent about how they achieve their results, detailing these technical innovations.
It helps push back against any whispers or claims that maybe they were just, copying someone else's homework.
Exactly. It demonstrates genuine engineering and research contributions. They're showing their work.
Okay, so let's pull back. What does this all boil down to for you, the listener? Why should you care about DeepSeek's efficient training methods?
Well, it fundamentally means that access to truly powerful AI is becoming less concentrated in just a few hands.
Right. When you have models like R10528 available openly under permissive licenses like MIT.
And when the methods to build such models become more efficient and are shared, even partially,
it dramatically lowers the barrier to entry. More developers, more researchers, startups, maybe even individuals with a good idea can actually experiment, build applications, and innovate using state-of-the-art AI.
without needing venture capital measured in the tens or hundreds of millions just to get started on the model side. It's a move towards, democratizing this powerful technology.
So let's wrap up this deep dive. Key takeaway. DeepSeek's latest model, R10528, is a serious contender. It's a top-tier open weights model challenging the performance of the big closed systems.
And crucially, the way they built it, focusing relentlessly on efficiency through techniques like mixed precision training and optimized communication, is potentially changing the economics of AI development.
They're demonstrating that cutting-edge AI might not always require an astronomical budget, which is huge news for the entire field.
Yeah, this work, combined with efforts from others in the open community, is genuinely shifting the landscape. It's making advanced AI capabilities more accessible and hopefully fostering a wider range of innovation.
So here's a final thought we want to leave you with. If these top-tier AI models can increasingly be built, run, and shared much more affordably than we thought, what new possibilities does that unlock? What kinds of innovation might emerge when powerful AI isn't just confined to the biggest labs? What does that future with more accessible AI actually look like?
Something definitely worth mulling over.
Absolutely. Thanks for joining us for this deep dive.